Alright, here we go. This is the last video for the unit. This is objectives 49 and 50, which is multiplying polynomials, but just those special cases. So I'm going to start off by just recalling something that we learned from one of the earlier objectives. So remember, x squared, what does that mean? It means multiply x by itself 2 times. So x times x. Using that logic, then if I have the quantity a plus b squared, then that means the quantity a plus b times itself 2 times. So a plus b times a plus b. This looks similar to what we learned in the previous video, FOIL. A quick note, we do not want to distribute the exponent inside. So do not distribute the exponent inside. What I mean by that is if I have a plus b quantity squared, do not distribute the squared to each term inside. A lot of us are going to want to say that this is equal to a squared plus b squared. This is not equal. In order for us to be able to distribute the exponent inside, the terms on the inside must be separated by multiplication. Because they're separated by addition or subtraction, we cannot distribute the exponent inside. So do not distribute the exponent inside. Instead, we expand it and FOIL. So let's practice doing that. Here we have the quantity g plus 4 squared. Let's rewrite that as g plus 4 times itself twice. So g plus 4 times g plus 4. And then from there, we can just use FOIL again. First, outer, inner, last. So we multiply the first terms. G times g gives us g squared. The outer terms, g times 4, gives us 4g. The inner terms, 4 times g, gives us 4g. And the last terms, 4 times 4, gives us 16. Remember, we always want to combine like terms. So we have g squared plus 8g plus 16. Let's do another. Here we have h minus 3, quantity squared. Let's rewrite that, saying h minus 3 times itself twice. So we have h minus 3 times h minus 3. Always rewrite and expand this square. We then do FOIL again. So first, h times h is h squared. Outer, h times negative 3 gives us a negative 3h. Inner, negative 3 times h gives us a negative 3h. And last, a negative 3 times a negative 3 gives us a positive 9. Again, we combine like terms. So we have h squared minus 6h plus 9. Let's do a couple more. Here we have a minus 6 times a minus 6. We're rewriting that, expanding it. We're going to use FOIL again. So first, a times a is a to the 1 plus 1, or a squared. Outer, we have a times negative 6 is negative 6a. Inner, we have negative 6 times a is negative 6a. And last is negative 6 times negative 6 gives us a positive 36. Combine like terms, and we have a squared minus 12a plus 36. Finally, we have 7 minus b quantity squared. We'll do the same thing. We'll expand it out to 7 minus b times itself 2 times. 7 minus b times 7 minus b. We do the same thing. FOIL. First, outer, inner, last. So we have first, 7 times 7. Outer, 7 times negative b gives us negative 7b. Inner negative b times 7, we have negative 7b. And last, negative b times negative b gives us a positive b squared. Combine like terms, we have negative 14b. And then I'll write this in descending order, descending power order. So b squared minus 14b plus a positive 49. Let's explore another special case of multiplying polynomials. So in this, instead of multiplying two binomials or a binomial squared, we're going to multiply binomials by trinomials, or any polynomial with another polynomial. In order to do so, we must multiply each term, every single term in the first polynomial with each term in the second polynomial. So in other words, we're going to multiply every term times every term. What I find helpful is to draw lines so that I can keep track of the multiplication. Again, we do the same thing. We want to combine all like terms. Anytime you can combine like terms and simplify the expression, you should. So let's practice. Here we have g plus 4 times g squared plus 7g minus 4. We have a binomial, 2 terms, times a trinomial, 3 terms. So we're going to multiply each term in the first polynomial with each term in the second polynomial. So let's just look at this first term of the binomial, g. We're going to multiply it by every term in the second polynomial. So let's start with g times g squared. Remember, this is just g to the 1. So we have g to the 1 times g to the 2, or g to the 1 plus 2, g cubed. Then we multiply by the second term. 7g times g gives us a positive 7g squared. Then the last term here, we have g times negative 4 gives us a negative 4g. So that was all of the multiplication for the first term. Let's multiply the second term by every term in the second polynomial. So we're going to distribute this as well. Here we have 4 times g squared is just 4g squared. 4 times positive 7g gives us a positive 28g. And then last we have positive 4 times negative 4 gives us a negative 16. We combine like terms. I see we've got a 4g squared and a 7g squared. We can combine that into 11g squared. I also see that we have a negative 4g and a positive 28g. So we can combine that into a positive 24g. And I don't see any other like terms, so we'll just bring the rest down. G cubed and a negative 16. Notice how I've written my solution in descending power order. This is the power of 3, power of 2, power of 1. This would be the power of 0. Let's try another. So again, we multiply each term in the first polynomial with each term in the second polynomial. So we're going to multiply this a times each term in the second polynomial. So a times a squared is a cubed. A times 10a is 10a squared. A times negative 6 is negative 6a. Then let's multiply the second term in the binomial with each term in the trinomial. The second term in the first polynomial with every term in the second polynomial. So we'll distribute that 5. We have 5 times a squared gives us a positive 5a squared. 5 times positive 10a gives us 50a. And then we have 5 times negative 6 gives us negative 30. Combine like terms. I see we have a 5a squared and a 10a squared. That gives us 15a squared. We've got negative 6a and a positive 50a gives us a positive 44a. And then we can bring down the rest. So the minus 30 and the a cubed. And that is our solution in descending power order. Again, multiplying polynomials, multiply every single term in the first polynomial with every single term in the second polynomial. That's objective 49 and 50.